Hey everyone, in this video we're going to install ROCm 5.3 in order to have a Pytorch and Tensorflow running on AMD GPUs. So just a quick recap on the hardware I'm using for this video. So this is my Asus G14 laptop, 2022 model, 6800HS and Radeon RX 67S for the GPU with 8GB of RAM. And it's a Ubuntu 22.10 kinetic Kudu. So this is the newest Ubuntu. These steps, however, works with 22.04 and 20.04. So it's about the exact same steps except for one difference I'm going to show later. So let's start. First, we need to update the repos as usual. And after, we get the AMD GPU installer. So all the steps in this video, I'm going to put the link down below with all the instructions so you can copy it. So to make this video, I copy paste the instructions to make sure that they're the same. So it's going to work. So after downloading the AMD GPU installer, we're going to install it. I already executed these steps, so in my case, it's already installed. I'm gonna skip that. So next step, we are ready to install ROCm, but before that, I'm gonna list all the use cases you can do with the AMD GPU installer. So you can do that by specifying the argument list use case. So first one, as you can see, is the kernel boot driver. So obviously this is to install the driver, the AMD GPU driver. But in 22.10 version, this actually breaks the installation because the kernel version is not compatible. I think I didn't dig more to debug how to fix that or work around that. But if you install it as is, it won't work. So we're gonna skip that. I'm gonna show you how later. So obviously we're gonna install ROCm, which is enough for Pytorch to run. But for TensorFlow, you need to install HIP runtimes and MI OpenLibs as well. So we're ready to install. So don't forget to specify no DKMS if you are using 22.10. Otherwise, it's going to break the installation. If you're on 22.04 with the default kernel or 20.04 with the default kernel, you should remove that. So as you know, in my case, I already installed, so I'm going to skip that step. After that, you need to add your user to the video group called video. This is for to be able to access GPU resource under your user, and also the render group as well. So you need to reboot after that, and if you want to check if it's was well added, you can type the groups command, and you're gonna see, like in my case, it should have video and render in it. Okay, so now we're ready to almost ready to try Pytorch. So we're going to git clone the Pytorch examples, the official Pytorch examples. And we're going to try the MNIST example. Just a simple example to make sure the setup works. At least the basics works. But before that, we need to install Pytorch, obviously. So for that, you can go to the pytorch.org website, and you can copy paste the installation command depending on your setup. So in our case, it's a Linux. We're using pip, Python, and don't forget to select ROCm. So the version is not exactly, we're using 5.2, ROCm 5.3, but 5.2 will work as well. So already installed in my case, I won't redo it. And now you're ready to, we're ready to run the example. Okay, so as you can see, it crashes because it doesn't find the right binary for your GPU. Because the reason is because you the RX 6700S is not officially supported by ROCm. So what we're going to do is we're going to override this. We're going to use this override so to pretend it's another GPU which has the same architecture, and it's going to work. For your own GPU, you need to check first if you need to do that, but the best way is to try. So as you can see, it's working. So next, I'm going to try Tensorflow. So TensorFlow ROCm instead of TensorFlow GPU or TensorFlow. So I'll install it, and I can show you my version. It's 2.10.0.530. So it should correspond to your ROCm version. And we're going to sync the official TensorFlow benchmarks for the GitHub and try ResNet 50 benchmark. So as you will see, the performance is not that great. It's about the performance I got on RX 580. It should be a bit higher, but I didn't profile where the bottleneck is, but I suspect it's because it's that TensorFlow ROCm level. Because when I run Pytorch, I didn't run Pytorch ResNet 50 yet, but I run other examples you're going to see later in the video, and the performance is much closer to what I would get on NVIDIA cards. But actually, that depends on the specific model you're running. Some models, some use cases are closer to the use case I guess the programmer at AMD are using to test and profile or prioritizing. So it really depends on your use case. Also, this normally should support 16-bit precision, which gives a big boost in performance, maybe 60% more in terms of performance, which I got on when I was using OpenSUSE Tumbleweed. So on OpenSUSE Tumbleweed was that flag was working, but on Ubuntu 22.04 and Ubuntu 22.10, it's not working. So as you can see, as you're gonna see, it's get a bit lower than the FP32. So I didn't get the flag right, but let's use FP16. I forgot. But anyway, it works. But the performance is not right. So it should be around 160 FPS, according to my test on OpenSUSE Tumbleweed, the same hardware, exact same hardware. So next, if you use an NVIDIA card before for machine learning, you probably know about NVIDIA SMI. So there's the equivalent is ROCm SMI. So you can see the two GPUs you have in the system. So the integrated GPU, number 1, and the number 0 is the dedicated GPU. You can see the GPU usage percent is stuck at 99. This is a bug. I'm not sure why. So either it's like 0 or 99 or a small number or a big number, but it's not showing the right value actually. So another thing is if you want to make sure that the GPU is at the maximum performance, you can use this command ROCm SME, set the performance level to high, so that it's always running at the maximum performance. This is sometimes necessary because it's not like the power management is not perfect depending on how you use it, so it's not managed perfectly. So you might get better performance if you set it manually to high than expecting it to put it high at the right time. So again, that depends really on which task you're running. Same for the CPU. You can use CPU power to put maximum performance on all CPUs. So it uses more power, but at the same time you're sure that that you're gonna get the power necessary at the maximum power you can have at all times. It does make a difference in a certain task, like when running when you have to run emulation on your CPU, like you emulate some games before sending the data to the GPU, but while the GPU is running, the CPU goes back to power save state. Power save state is the problem is that when it's time to go back to performance state, it takes a while, and that time reduces your performance. It can make like a 10-20% difference depending on the CPU you have. So you can check with these commands, like the scaling governor. You can check all your cores at their performance, and also the speed of all your cores to make sure it works. Also, you can use ROCm bandwidth test on Ubuntu 2010 and 22.04. It doesn't work. Not sure why. It just crashes. Not found. Well, this is another problem. I have to specify the full path. But on the OpenSUSE Tumbleweed, it actually worked, and I got. You should expect about 14 gigabytes second from host to device transfer, and device to device transfer about 200 gigabytes second if you're using my GPU model. So unfortunately, I cannot show you the results because it doesn't work. Okay, so another thing is that if you okay, there's only one install too much, but you do sudo apt install RCCL. If when you run TensorFlow you have RCCL missing lib error message, some type of this kind of error message, you have to install RCCL manually. If you have other libs missing, usually it's because you didn't specify all your use cases in the ROCm installer at the beginning of the video. So make sure you get everything right at the beginning of the video. You can check the libs you need to install. Also, this command is to check if what AMD GPU version you have. So yeah, if you have some strange bugs or your ROCm recognize your GPU, make sure you have the recent version of AMD GPU. So in our case, it's 22.10.3. Okay, so this is an example of a machine learning models training on games. Actually the performance, this is using Pytorch and the stable baseline 3. And the performance is quite close to what I get with my dual Xeon 2663 and the RTX 2060 Super 8GB of RAM of VRAM. The training FPS is around the same. So that's quite surprising because the RTX 2060 Super is a bit stronger than my mobile GPU. I would expect maybe 25% stronger or 30% stronger, but the end result is the same training FPS. I didn't profile. I did profile the an NVIDIA version on the NVIDIA side, but I didn't profile on the AMD side yet to determine where exactly where is the bottleneck. Is it because of the CPU actually? Because single core performance is better on the 6800HS, the Ryzen 7 6800HS, than on the Xeon 2666 V3. So maybe that's has to do with it. Or ROCm actually supports this type of CNN model better than CUDA. I'm not sure yet, so I need to profile. But actually that's good news because using TensorFlow 1.14 back like a couple of years ago on the RX 580 versus GTX 1060 type of card, there was a huge difference. It was almost double. The NVIDIA card was double, so it's good that they catched up. So here we're running just an example hang-on the Sega Master System. So just to show that the system works well. It's actually the base of this model. I trained it on the NVIDIA card, and I continue training it on the AMD card. Okay, another trick is for performance. In case you have performance issues, you can set your number of threads for Pytorch to 1 when using the GPU. Sometimes its default is way too much, and it actually bugs down the system for some reason. And again, that depends on your use case and the particular context, but you need to try it. Also, if you have multiple GPUs, you can use ROCr visible device. So 0 for, in my case, for the dedicated GPU, 1 if you want to use the iGPU, but it's not supported. And you empty, you put no number for if you want to force use the CPU for some reason. So that's it. Please don't forget to like and subscribe. If you have any questions, please don't hesitate to ask down below. See you next time.